Okay, let us try to plot y equal to e power x by 1 plus e power x. So you can see the domain of the function is R, as I don't see any poles in the denominator. So e power x is defined for all values of x, and for it to be not defined, the denominator should be 0, and I don't find a value of x for which the e power x is minus 1, making the denominator 0. So the domain would be R. Fine. Next, I can also see that the function is always positive, as e power x is always greater than 0. So there is no negative side of the function, as both of them, numerator and denominator, are greater than 0. So wavy curve of equation is done, and the domain is found. Now let us go to the first derivative of the function. So the first derivative of the function would be obtained by u by v rule. So u dash v minus v dash u by v dash v whole square. So that would be this, and you can see that e power x is always greater than 0, and 1 plus e power x whole square is always greater than 0. So y dash is always greater than 0. That means the function f is increasing. So you can see that from the in the range R, the function is always increasing. Next, we need not find the double derivative, as we already have enough information to draw the graph. So now we see what is the nature of the curve as x tends to infinity. So let us find the limit as x tends to infinity. So directly I cannot substitute this infinite by infinite, I can do L'Hospital. So e power x, again I'll get the same thing. E power x differentiation is e power x plus 1 plus e power x, again 0 plus e power x. So that would be 1. There is one more way to do that. Take e power x common here. So that would be looking like this: 1 by 1 plus 1 by e power x. If you substitute x tends to infinity, that would be 1. Similarly, if you substitute x tends to minus infinity, that would be 0. So that means the function tends to 1 at x equal to infinity, and x tends to infinity, and the function tends to 0 at x tends to minus infinity, which should be the case as the function is increasing. So at x tends to minus infinity is 0, and x tends to infinity it is 1. And let me find the value of the function at x equal to 0, which would be 1 by 2. So this would be the graph. So at x tends to minus infinity, value is tending to 0, and x tends to infinity, value tends to 1, and y of 0 is 1 by 2. So the range is 0 to 1, both not included. Next, so this is how you plot the curve y equal to e power x by 1 plus e power x. There is one more way to do, easier way to do that. So what you can do is you can consider e power x plus 1 as t, and if you consider that, then the y will be t minus 1 by t. So t minus 1 by t you can write as 1 minus 1 by t. So 1 minus 1 by t, with t ranging from 1 to infinity, as x equal to 0, as the limit of e power x is 0 to infinity, the range of t is 1 to infinity. So 1 included and 0 infinite not included. So if you substitute it as 1, you will get a 0, and if you substitute infinity, that would be 1. So you can plot the curve in this way too. Thank you.